Hi, my name is Alanna Cooney, and I'm a fourth-year PhD student in the Energy and Multi-Phase Transport Laboratory at UC Berkeley, working for Professor Van Carey. My research focuses on thermal energy storage. The motivation behind thermal energy storage research is the fact that the availability of renewable energy resources doesn't always align with the demand for energy. One example being heating your home at night when solar energy isn't available. Therefore, thermal energy storage, where energy is stored as heat, can be used to store renewable energy to be later used on demand. Two of the main applications of thermal energy storage are in building heating and cooling systems, and also in solar power plants, where heat can be stored during the daytime and then used to generate steam for a power plant at night. My research specifically focuses on how to design and operate thermal storage systems in the most energy efficient way possible, which would allow us to maximize the use of renewable energy. To do this, I use a concept called exergy. Exergy has the same units as energy, but is more useful because it describes both the quantity and the quality of energy. A simplified example of quality of energy is the difference between a mug of very hot water and a kiddie pool full of lukewarm water. The two may have the same quantity of energy, but the mug of hot water has a higher quality of energy because we could do more with it. For example, if we wanted to make a cup of hot tea, we would want to use the mug of hot water as opposed to the kiddie pool of lukewarm water. Another way to think about it is that it would be far easier for us to turn the mug of hot water into a kiddie pool of lukewarm water by simply mixing it with some cold water. And it would be much more difficult to turn the kiddie pool full of lukewarm water into a mug of steaming hot water, since that would require some additional inputs of energy. The aspect of exergy that I'm particularly interested in for my research is the destruction of exergy, or the destruction of high-quality energy by my thermal storage system, which is shown here. Therefore, in my research, I designed optimization schemes which allow me to determine the best way to operate this thermal storage system, which minimizes the exergy that is destroyed when storing and extracting thermal energy. I can then train artificial neural networks to learn to control these thermal storage systems to allow them to operate as efficiently as possible. And so far, my research has shown that I can reduce exergy destruction by 30% using these methods. Lastly, I would like to thank ARCS for giving me the opportunity to pursue my PhD at UC Berkeley and for providing me with the funding to work on sustainably focused research. I'm very thankful for this opportunity and hope that my research will contribute to efforts to reach a net zero carbon future. Thank you so much.